Now this is my another video in continuation of my earlier video on composition of functions. So the topic is again composition of functions. The topic is again composition of functions. I have already told you that what is a composition of function. Composition of function is composition of two or more functions in such a fashion that the output of the previous function is being taken as the input of the successive function. Now let us say f is a function from a to b, that is domain of function f is a and the codomain of function f is b, and say g is a function from b to c, that is the domain of function g is b and codomain of function g is c. Then we can combine these two functions. I will let first f function to happen and then g function to happen, so the combination will be GOF. Combination will be GOF. And one thing to be remembered, one thing to be noted here, that the codomain of B and the domain of G are identical here. That is, G is taking its input from B set, which is the output region of the f function. This is very important. If I consider another function, say h, from say d to say c, then it will not be possible to combine this h function with this f function, or h function with the g function, because the output of f is b whereas the input of h is d. So h is not collecting its input from the region where the output of f function or output of g function is being given. That is, the output or the codomain or the what we may say safely, the range of the previous function should be capable of delivering itself as input of the next function. That is, it should fall in the domain region of the successive function, that is g function, so that we can combine these two functions. Here if we consider say FOG function, if it is existing or not. GOF function is existing because GOF means what? First F and then G. GOF means first F and then G. This is first happening and then this is second thing. First F is happening means the codomain of F is B and the domain of G is B, so it is matching. We can combine them then. But in the case of FOG, it means first G and then F. First G means the output of G is in C and the output of and the input of F is A, so it is not matching. So FOG is not possible, whereas GOF is possible in this particular case. Now let us take this one. This is the f function. So this is the domain of f function and this is the codomain of f function. So this is the f function from A to B. and B2C is the G function. Let us keep this one, and this is C function. This is the G function, which is taking input from B and throwing its output at C set. This is the set of elements constituting domain of a function. This is similarly set of elements of codomain of a function, B set, and again B set is the set of elements of the domain of G function, and C set is the set of elements of the codomain of the G function. So this is F and G. Now from here everything is going to here as fx. Whatever element you can see here, this may be called as x. Whatever element is being thrown here, this may be called as fx, and from there everything is going here as GOF of x. So if we consider this one in this way, that GOF is a function from A to C. GOF is a function from A to C, that is taking x as input and giving GOF of x as output. I must mention that GOF of x means what? G of fx. I have already told it in the earlier video that GOF x is equals to G of fx. So here what it is happening is that GOF is a function from A to C. We can say about it, that is, whenever I am combining f and g functions, where f is a function from A to B and g is a function from B to C, it means GOF is a function from A to C, and this is the composition of these two functions. So we may say that this is the f function, and maybe this is the b function, and maybe this is the c function, and GOF is like this. GOF is like this. Here it is taking as x, and here it is throwing GOF of x. If we want, we may not mention about b, because b is irrelevant here. When composition of f and g has happened, then b set has gone, because GOF function, its domain is A and codomain is C function. So this is very important to consider, that if there are two functions f and g, they can be combined provided certain thing matches, that is, the range of the first function should be capable of delivering its output, or if a range of the first function should be in the region of domain of the second function. In this particular case, GOF is possible, but f of g is not possible. And if I consider another function h, d to c, it cannot be combined with f and g in this way. That is, if I consider this one, see, HOF is not possible. I am writing this one here. Say f is a function from A to B, g is a function from B to C, and h is a function from D to C. Now let us try to make a composition of these two functions with h. Now HOF, is it possible or not? HOF means first of all f function should work, and then the h function. If f function is allowed to work, then it will take input from some A set and it will deliver its output to some B set. whereas H function is ready to accept input from D set, so it will not work because it will not get the output of F function. The output of F function is being delivered to B set, so it will not work. Whether FOH is possible or not. FOH means what? H function will be allowed to act first and then the second function is F. If H function is allowed, then H function will take input from D and its range is at C. And then the F function will take input from A. So these two are not matching. It will not be able to accept or collect input from the output of the H function. So it is not going to happen. Now let us consider HOG. HOG function. In this case, G function will act first and then the H function. So G function, its input is B, domain is B, G function, and its range is or codomain is at C. So it is throwing its output at C, whereas H is going to take input from D. So these two things are not matching. So it is not going to happen. Now let us say its inverse, that is GOH, if it is possible or not. GOH means H first and G second. First of all H, that means D to C. And G means B to C. So these two are not happening, not matching. So this is also not possible. So while combining two functions, then keep these things in your mind. Now in the later video I will tell you another interesting thing, that if the codomain of the first function and the domain of the second function does not match exactly, then also how can we obtain composition of functions.